Welcome students to today's session of ALPHORES e-learning program. Yesterday we have studied about heat and temperature, and we have given the basic ideas about temperature and heat energy, and we said heat is a form of energy and temperature is the effect of heat energy. We have given different concepts about the temperature. Temperature, first we said it is the level of heat energy. It represents the level of heat energy contained in a body, right? That means if you consider a body, when it is having more amount of energy, the temperature is large. Otherwise, if you say the temperature of the body is more, the energy stored in the body is more. For the same body, when the temperature is less, heat energy present is also less. And then another concept of temperature is, according to that, whenever the heat energy is flowing, suppose there are two bodies are in contact, then heat energy will be flowing from high temperature to low temperature. Then we said, if two bodies, let us say a block A and another block B are placed in contact, whether the heat energy flows from A to B or B to A, that is decided by temperature. So temperature is a physical property of the body which decides the direction of flow of heat energy when two bodies are kept in contact. So we have given some basic idea about the temperature, and now yesterday itself we started about measurement of temperature, how to measure the temperature, right? Now let us go for it. Now before going to that, let us discuss one more important point here, that is called thermal equilibrium. If you remember yesterday's topic, we have taken on a table, we placed a container having some water, and in this water we added some ice. On the same table we have taken a hot drink like coffee or tea, which is hot. Some hot liquid we have taken here. Initially they are at the placed in the on the table at the room temperature. After some time, what we said is, this is cooling to room temperature, this is also getting cooled to room temperature. That means here initially the water is at the room temperature, and from the water ice is taking energy, ice is converted into water, water is getting cooled, and finally it reaches the temperature of the room. So whatever is room temperature, the final temperature of this body is the same. Until then, try to understand, until the temperature of the water produced here is becoming equal to the temperature of the room, there is continuously energy is taken away by the water present here from the room. Heat energy is flowing in this direction, the water is taking. And similarly here you have taken some hot liquid, but here from this hot liquid heat energy is flowing out, and until the temperature of this hot water becomes equal to the room temperature. Let us say room temperature is T0. Initially they are at some high temperature T1 and this is at a temperature T2. After some time we can see this is neither hot nor cold, which means that the temperature of this one is also becoming equal to T0. That means from a temperature T1 it is getting cooled to T0. After that we don't find any change in temperature. That means previously the hot liquid present here is losing heat energy to the surroundings, to the room, surrounding area, or surrounding air particles will take away energy. But once the temperature of this room body becomes equal to the room temperature, initially T1, now it has come down to T0, then there is no transfer of energy. Similarly here also, initially this water is cooled because of ice placed in it, but after some time, as we said here, it is taking heat energy from the surroundings, heat energy is flowing like this, and finally this is also reaching the same temperature as present outside, that is the room temperature T0. Initially it is a T0, but now this is also cooled to T0. That means what is happening here? Whether you take a hot body or cold body, their temperatures may be totally different, but when they are placed on the table at the room temperature, both are getting cooled to room temperature. Until then, here energy is taken outside from the body to the surroundings, and here energy is taken from the surroundings to the body. So there are energy transfer is taking place. There is a communication that is called thermal communication. That thermal communication is taking place. Energy is transferred. But once the temperature of these two are becoming equal, that is temperature of this content is equal to temperature of the room, then there is no transfer of energy between the container and the surroundings. And here also, once the temperature of this hot liquid becomes equal to the temperature of the room, there is no transfer of energy. Then what we say, until then there is a transfer. When the temperatures are becoming equal to the room temperature, no transfer of energy is taking place. That state is called thermal equilibrium. Thermal equilibrium. That means under the state of thermal equilibrium, no transfer of energy will take place. But we said previously, heat energy always flows from high temperature to low temperature. That means there is a temperature difference. As long as there is temperature difference, energy transfer is taking place. But once the temperature difference becomes zero, temperature of both the bodies are becoming equal, there is no transfer of energy. Therefore, using this phenomena, we can define one state called thermal equilibrium. Then, related to this thermal equilibrium, there is an important law that is called Zeroth Law of thermodynamics. Actually, we study this law again in thermodynamics, but because it is related to the concept of thermal equilibrium, I am discussing here. What is that? Suppose there is a body A, and let us consider another body B. This is a body A, this is another body, and suppose let us consider another body C. You can say that there are three systems or three bodies, and now let us suppose A and C are in thermal equilibrium with each other. A and C are in thermal equilibrium with each other. What do you mean by that? When you say they are in thermal equilibrium, we mean that there will be no transfer of energy between them. That means there will be no transfer of energy from A to C or C to A. Then we say that they are in thermal equilibrium. Then that means the temperature of C and let us say temperature of A, these are the values of temperature. Temperature of B, let us say TB. Now let us see, there is no transfer of energy. Let us compare this with the previous example we have studied. We have taken ice cubes and hot liquid at the room temperature, but they are getting cooled to room temperature finally. That means transfer of energy is taking place until there is a temperature difference. If once the temperature of both the bodies are becoming equal, there is no transfer of energy. Here we are seeing the same condition. We said that A and C are in thermal equilibrium. That means there will be no transfer of energy from A to C or C to A also. That means the temperatures of A and C are equal. Temperatures of A and C are equal. So note that. Here we said A and B are in thermal equilibrium. From that what we can conclude is temperature of A equal to temperature of C. Temperature of A equal to temperature of C. Now suppose B is also in thermal equilibrium with A, with B. C is also in thermal equilibrium with B. What does it mean? There is no transfer of energy between B and C also. So no transfer from C to B or B to C. Then what we can conclude? Temperature of B and temperature of C are also equal. Very clearly, these two are in thermal equilibrium. Then we said temperature of A and C are equal. When these two are in equilibrium, the temperatures of these two are equal. Very clearly, Tc, the temperature of C is equal to that of B and also that of A. That means temperatures of system A and temperature of the body B both are equal. That means they are also in thermal equilibrium with each other. So this explanation, if you make it as a principle or a theorem or a law, what we can conclude? When two systems A and B are in thermal equilibrium with a third system C, then they will also be in thermal equilibrium with each other. So here A and C are in thermal equilibrium and B and C are also in thermal equilibrium. But from that what we have concluded, A and B are also in thermal equilibrium with each other. That means when there is no transfer of energy between A and C and also between B and C, there is no transfer of energy between A and B also. That means both are also at the same temperature. Because as long as temperature difference is there, then only there will be a transfer of energy. Once the temperatures become equal, there will be no transfer of energy between them, and that they reach the state of thermal equilibrium. So from the state of this thermal equilibrium, we can understand that when the two bodies are at the same temperature, there will be no transfer of energy between them, and then we can say that the two bodies are in thermal equilibrium. Now, after knowing the state of thermal equilibrium, the importance of this law, Zeroth law of thermodynamics, this is known as Zeroth law. Zeroth law of thermodynamics. The importance of this law is this law gives the concept of temperature. This law gives the concept of temperature. Because suppose you take two containers, one is having water to a larger height, and by the side I have taken another container which is having water only up to a smaller height. Suppose these two are connected. When these two are connected with each other, you can see flow of water will be there from the container where the level of water is more to the container where the level of water is less. Here, what is the deciding factor is level of water. Level of water will decide the direction of flow of water, and this flow will take place until the water levels in both the containers become equal. Once the levels of water in both the containers become equal, there is no transfer. That means the transfer of water, the flow of water, the direction of flow of water, and how much quantity of water is to be transferred, all these things are decided by a property, that is level of water. Similarly, let us consider two bodies, let us say A and B, so far that we have discussed now. Now when A and B, what is the property which decides the direction of flow and until what conditions the energy will flow? So definitely, just like the level of water, there should be a parameter. There should be a property which should decide the direction of flow and how much energy is to be flowing from one body to another body. All these things that can be decided by one single property that we named as temperature. Temperature. So temperature is the property which decides the direction of flow of heat energy and how much of heat energy is to be transferred from one body to another body. And that concept of temperature we can understand from this Zeroth law of thermodynamics. That is the importance of this Zeroth law. And in detail about this law, once again we can study in the topic of thermodynamics. But now let us move on to the measurement of temperature. Measurement of temperature. How to measure the temperature? Yesterday I told you temperature cannot be measured directly. Temperature cannot be measured directly. Then how to measure that? For example, I told you yesterday also, if you have some fever, when you approach a doctor, to measure the temperature of the body, they will be placing a thermometer in the mouth, or sometimes the doctor will place a small metallic, small strip on your forehead that gives the readings there. There is a digital thermometer. All these cases you are directly getting the reading, but the method of measurement is not direct. Method of measurement is not direct. Then what is the principle involved there? Then temperature can be measured by the effect of temperature. What do you mean by effect of temperature? There are some physical properties of the bodies which will be changing by increase of temperature or decrease of temperature. That means you consider a property which depends upon temperature of the body, and whenever the temperature changes, the property also changes. Then by measuring the change in this property, we can measure the temperature. By measuring change in the property, we can measure the temperature. And such property is called thermometric property. Thermometric property. Thermometric property. What do you mean by this? It is a physical property. It is a physical property of a body which considerably changes with the temperature, measurably changes with temperature. That means the changes should be measurable. If the changes are very small, you cannot measure. If the changes are large enough, then only we can measure. Therefore, let us define this property, thermometric property. What do you mean by this? It is a physical property of a body or a material which will change considerably or measurably with the temperature. That means when the temperature is increasing or decreasing, the properties will change. What are the examples? When you change the temperature of a body, yesterday I told you, you will have thermal expansions. Thermal expansions. What are thermal expansions? When a body is heated, there will be an expansion in length of the body or volume of the body. There can be change in the volume and pressure of a gas. There can be changes in volume and pressure of a gas, and there can be change in density also, because volume is changing. The density we define as the ratio of mass and volume. For any body, mass is constant, but with the temperature, volume is changing. As volume is changing, density will also be changing. So these are called thermal expansions. So whenever the temperature of a body is changing, all these properties will undergo changes. That is, there can be an increase in the length of the body, or increase in volume, or pressure of in case of liquids we study about change in volume, but considering the gases, there can be an increase in volume or pressure, or in case of liquids and gases, there will be a change in density. All these are changes taking place only because of change in temperature. So they can be considered as thermometric properties. Thermometric properties. And apart from that, there can be a change in resistance of a wire. Resistance of a wire, that is electrical resistance. For a given electrical conductor, you have studied about Ohm's law in the lower classes. According to Ohm's law, the current passing in a conductor is ratio of potential difference applied to the resistance of the conductor. So resistance is an opposition for the flow of current in the conductor, which depends upon temperature. So as the temperature is changing, resistance of the conductor will also be changing. So we can consider the resistance as a thermometric property, because it is effectively changing with the temperature. So this is a thermometric property. Now coming to other properties, there is a method called thermo EMF. By varying the thermo EMF with the temperature also, we can measure the temperature. What do you mean by EMF? When we go to buy a battery, a sealed battery, when you observe, you will see it is having a potential difference of 1.5 volt. So that means the battery can produce a potential difference of 1.5 volt. That is called EMF of this battery. Then what is thermo EMF? It is observed that in certain cases of metallic junctions, suppose you take one copper wire and another metallic wire like some iron, let us suppose. So when you join them like this, there is a junction where copper wire and iron wire are meeting, and here there is another junction where iron wire and copper wire are meeting. And when there is a temperature difference developed between these two junctions, suppose one junction is maintained as a hot junction and second one is maintained as a cold junction, there is a temperature difference, then we can see that then EMF, electromotive force, is developed between these two junctions. That is called thermo EMF. Thermo EMF. So this thermo EMF is a property which depends upon the temperature difference between the two junctions. So thermo EMF can be considered as a property which is useful to measure the changes in temperature. That means it is also a thermometric property. It is also a thermometric property. Now, after this thermal EMF or thermo EMF, let us move on to another example of thermometric property that we study. With the temperature, radiation coming from a body, the intensity of radiation, I can say. Intensity of radiation coming from a body can also be changed. When you can see, when you are very close to a high temperature body, we feel very hot. When you are standing near some cubes of ice or large ice cubes, we feel cold. So when the temperature is changing, energy radiated by the body will change. By measuring the intensity variations coming from radiation, we can measure the temperature of the body. So intensity of radiation coming from the body can also be used to measure the temperatures. Practically, there are some instruments called pyrometers, which are used to measure the temperature of bodies whose temperature is very, very high. Like the temperature of the sun. Temperature of the sun directly we cannot measure, but we measure the temperature of sun by detecting the intensity of radiation coming from the sun. So this can also be considered as a thermometric property. And sometimes color of a body can also be influenced by the temperature. Color of the body also influenced by temperature. So by changing the colors also, we can find out the temperature of the body. So this can also be considered as a thermometric property. Now, to put together what are thermodynamic properties, let me repeat quickly. Thermometric property is a property which is useful to measure the temperature and which considerably changes with the temperature. And we have given so many examples. Thermal expansions, expansions in length, expansion in volume of liquids, expansions of changes volume and pressure of the gases, right? All these things can be used. Or variation of density, it can be used to measure the temperature. All these come under the category thermal expansions. Next one, by intensity of radiation and color, resistance of a conductor and thermo EMF, all these are thermometric properties. That means by changes taking place in any of these properties, you can measure the temperature. Now, out of all these things, when we consider the expansions, of materials, here we consider only expansions of liquids and gases to measure the changes in temperature. If you consider expansions, we said there can be expansion in length, expansion in volume, pressure, density changes. Then out of all these things, why we are considering only changes in case of liquids? Because solids will expand, liquids will expand, gases will also expand. But expansions, when we are defining the thermometric property, we have given a statement. Thermometric property is a physical property which measurably changes with temperature. Measurably, that means if the changes are not measurable, if the changes are so minute, you cannot use them to measure the temperature. You should be able to measure the changes, then only it is suitable. So generally, expansions of solids, for example, you take a meter scale. The meter scale, suppose this end is 0, this end is 100. It will be having 100 centimeters of length at a particular temperature only. But the same metal scale, when it is used at a very high temperature, because of change in temperature, definitely it will expand a small amount. But we cannot measure the small changes in temperature, so that using these small changes, you cannot get any information about the changes in temperature. That's why, due to small changes of length or area or volume also, in case of solids, we cannot use them as the thermometric property. So most of the cases we use only expansions of liquids and gases to measure the temperatures. So most of the cases we are using volume expansion. Volume expansion of liquids. Volume expansion of liquids is used as a better property of measuring temperature or a thermometric property. Especially why we are using expansion of liquids. When compared with solids, expansions of liquids are large. So easily they can be measured. For a given change of temperature, change in the volume of liquid is very much larger than the change in the volume of the solid having same initial volume. So volume expansion of liquids is most suitable, and in day-to-day life, all the thermometers we are using, wherever we go generally, except the digital thermometers, you can have mercury thermometer, you will have alcohol thermometers. Most of the cases in day-to-day life, we see these type of thermometers. So alcohol thermometers are the mercury thermometers. They are based on expansion of the mercury or alcohol, which is a liquid. Now, out of all the different types of liquids, we prefer mercury as thermometric property, thermometric material or thermometric substance. What is the importance? When you are using a particular liquid as a thermometric liquid or thermometric substance, what the properties it must have, and why we are preferring mercury only as a thermometric property when there are so many liquids. Remember, there are so many liquids, but we prefer mercury only as thermometric property in most of the cases. Of course, alcohols are also possible, but why we prefer mercury as the thermometric property is important for us. Then what is the importance? Number one, mercury has a very small, or it is having low specific heats. Low specific heat. What do you mean by specific heat? It is the amount of heat energy required to rise the temperature. For example, if I have given a small amount of energy, because of the small amount of energy in one liquid, there is a change in temperature only about 0.1 degree centigrade. But for the same amount of energy in another liquid, change in temperature is 4 degrees centigrade. Now, which we have to use? Which we have to use to measure the temperature? Here there is a small change. We cannot observe that clearly. But here there is a large considerable change which we can measure very easily. So this is more preferable. That means when you are supplying the same amount of heat, here the change in temperature is very small. Here the change in temperature is large. This is because of what is called low specific heat. And the property, the mercury is having low specific heat, and this should be one property of a thermometric liquid. And mercury is having that property. Remember, thermometric liquid must have low specific heat, and mercury is having that low specific heat. That's the first importance. Number two, it is having large conductivity. Large conductivity. Mercury is having large conductivity. That means easily it can take away energy very fast. You can see when you put a thermometer in hot water, immediately you can see a rise in temperature, rise of mercury column very fast, because very quickly it will take away heat energy from the substance with which it is in contact. So it is having large conductivity, so that changes of temperature can be very fast. So that's why we use mercury. And number three, mercury is the only liquid, it is the only liquid at room temperature. At room temperature, it is the only liquid. And remember, it is a metal. Remember that all metals are characterized by large conductivity and low specific heat. Mercury is having these two properties only because it is a metal. Low specific heat and large conductivity are the two properties of metals, and mercury is the only metal present at the room temperature in the form of liquid state. That's why we prefer. And apart from this, to measure, as we said, expansion, thermal expansion must be large. When the expansion is very small, you cannot measure. But for the same change of temperature, expansion of mercury is very large. We say that coefficient of expansion is very large in case of mercury. That means if you take 1 liter of mercury and 1 liter of water, for same change of temperature, for both of them suppose change in temperature is same, but you can see a large expansion in volume in case of mercury, and this expansion is very large for mercury. So even for small changes, change in volume is very large. Conveniently you can measure the change in temperature. That's why we prefer the mercury as thermometric property. And another one, this expansion is large. Not only that, this expansion is uniform. Uniformly it expands. When the temperature is increasing from 2 degrees to 3 degrees, change is 1. When it is increasing from 99 to 100, then also change is only 1. But in both the cases, the expansion of mercury is uniform. That's why we prefer this. And another important property associated with mercury is it has large boiling points. Boiling point, that means at very high temperature it required to boil. If it is converted to vapor, you cannot measure. For example, you take alcohol thermometers. Alcohol can be evaporated even at a large temperature. Even at room temperature, some alcohols will be vaporized. You cannot measure large temperatures using alcohols. But mercury, the boiling point is very high. Some hundreds of degrees centigrade temperature you can measure with the help of mercury. And about over and above all these properties, the mercury has a shining property. A shining property is there for mercury, so that you can easily observe the shining property. It can easily be visible. When you are pouring mercury in a glass tube like thermometer, you can see the mercury levels clearly because it has shining property, clearly visible. So there are so many merits with the mercury, so that the mercury can be preferred as a thermometric property because of all these reasons. I am repeating briefly first. Mercury or any substance, any liquid which is used to measure the temperature must have low specific heat, large thermal conductivity, and these two properties are very important. And expansion must be very large, and it should be uniform. It should be uniform, and it should be clearly visible, and all these properties are associated with mercury. So that's why mercury is the most preferable thermometric liquid. But sometimes we said alcohols also we use. Alcohols, they will be evaporated very easily even for a little bit higher temperatures. Even at when the temperature goes to some 45-50 degrees centigrade, alcohol evaporates. So alcohols cannot be used for very high temperatures. But because of large boiling point, mercury can be preferred as a thermometric property. Now, how to use this thermometric properties to measure the temperature, that we will do in the next class. And once you go through all these properties of mercury, which makes it most suitable for as a thermometric property. Let us stop here, and tomorrow we will continue with measuring systems of temperatures or different scales of temperature. How to devise different scales, how to measure the temperature, we will discuss tomorrow in the next class. Thank you very much.